Transformation style. Standing at the origin, 50 upside down. Then it's a reflection, spun it round. Right angle, that's rotation. That is rotation. Sideways, 2 units to the right. Yeah, sideways, 3 units up. Sideways, that's called a translation. So a flip, a spin, a slide, and below the round station. It's a reflection, and slide, it's a translation. If you spin, it's a rotation. Transformation style. Transformation style. Transformation style. Transformation style.
Well, I hope you enjoyed that transformation style little music video song. I thought it was kind of fun with that little, I guess that was a duck or something like that, going around the coordinate plane. Well, here we are with Big Ideas 4.3 for our geometry. We're looking at rotations. So this is the third transformation. So that's what that video is even going through, the different transformations with translations and reflections, and now we're looking at rotations. So we're going to be performing some rotations. We're going to be performing compositions with rotations. Remember, compositions just mean more than one transformation. So that could include a reflection and a translation with a rotation. And then we'll look at rotational symmetry. We saw kind of reflectional symmetry with reflections, but now we're going to also look at rotational symmetry. First, let's take a look at a little cartoon. There's in the bleachers. It says, we're in the operating room. Doctor says, suture. Let's move it. We're losing him. Wait, the game is tied with 5 seconds left. LeBron has the ball. Oh boy, you're going to lose him. So, not a good idea to have the big screen TV, I think, in the operating room with the game on. All right, so into rotations now. So our rotations here, our core concept on page 104, you can see we got a rotation is, like it said, spinning the figure. So you're going to spin the figure as a rotation, but you're always going to spin it over or around a point. Even if you remember back when you were little and you played with a top, you would always spin that top, but there was always a point in what you were spinning it on. Sometimes the tops it came to a point and you would spin it. So you're rotating it always around a center of rotation, and so that's what that is. It's a fixed point. So right here you want to put down, I'll mark it down here. Let's go red for this one. So rotation, you can highlight this part, rotation, but it is a transformation in which right there the figure, actually maybe I can't do it with that one. There it is. Transformation in which the figure is turned about a fixed point, and that fixed point is called the center of rotation. So rays are drawn from the center of rotation to a fixed point and its image, and they form the angle of rotation. So your angle of rotation right there, you can see it was be 40 degrees if that was it. Your P is your center of rotation, and so you can always rotate it on that, about that amount. Typically, when we do rotations, we're not going to do rotations on something that's 40 degrees. That angle, usually we're going to keep it at a like a 90-degree angle. So our ones we're going to rotate are really going to stay with 90, 180, 270. 360 would rotate it all the way back around onto itself and map it back onto itself. But you got the idea, I think, of rotation. It's going to rotate around a fixed point. So you're going to spin it around a fixed point. Now that fixed point could be on the figure itself, and now it's just kind of spinning around like this. But you can see that if that fixed point is somewhere off of the figure, then it's going to be moving around that figure. It's going to be rotating around the figure. So as you can see. Here we are onto the rules now. So these are the important ones. This is the important core concept. You're going to keep wanting to go back to this one. And this is the rules for 90, 180, and 270, which is the ones we're going to be doing. So your point, it says AB. So AB would be just the ordered pair of the point that you're going to want to rotate. And that could be several points that you have to rotate with a figure that's a triangle, or even 4 points if it's got a square or a rectangle. Now this is always going to be rotating it about the origin, so your center of rotation would be about the origin on all of these. Now it will always say that. You'll say where your center point is, and this one's going to be about the origin. Now if your center point was not the origin, what you'd want to do is you want to kind of do what they call as crosshairs. You want to kind of make crosshairs, which is like the coordinate plane, and think of that point as the origin. So your center of rotation would always be thought of like the origin, even though it might not be the actual origin on the coordinate plane. So you would use crosshairs to kind of use that as like that's your center point. I might show you a video like that on that eventually, but for now our rotations here are always going to change our x and a y a certain way. So when you're rotating about the origin this many degrees, you're going to be changing x and y. You're going to be just changing the numbers, and the x number would there become negative. As you can see that, though, if AB is here in the first quadrant, which is positive and positive for both x and y in the coordinate, and it rotates 90 degrees this way, well, now it's in quadrant 2 where the x is negative and the y is positive. The numbers, though, however, are going to switch. So let's say you have a 2 and a 3 here. Let's just, say that 2 and 3 here. Then that would be 3 and 2 here. But the 3 would then become negative. Your first one's going to be negative. And when you rotate it 180 degrees, well, that's going to be now putting it down to the third quadrant where it's negative, negative, where both x and y are negative. So really, you're changing the sign of both of these if you're going to rotate it 180 degrees. You can see that even here, if I rotate the red one here 180 degrees, I'm over here at the black one, and on that one they stayed the same direction. So you can see it's not going to change the numbers at all. A is still here, B is still here. It's just changing them both to be negative. Same thing here. If I rotate it 180 degrees from 2 to quadrant 4, the numbers will stay the same. So it goes B then A, so it's still B then A, but they both change to their opposite. So negative B is now positive B, positive A is now negative A. For a 270, that's going to go all the way from here all the way around, and so now we're into quadrant 4, and that's going to be where your x is positive but your y is negative. So it's going to also switch numbers, so it will switch the numbers, but it will make the y negative. It will be the opposite sign for the y. The x number will stay the same number, or same sign I should say, not the same number, but the same sign for x, but this one will stay turned to its opposite. So you switch them, and the y will turn to its opposite then. All right, so one last thing here. It says that this postulate for 4.3 is the rotation postulate. It just means that a rotation is a rigid motion. And we saw that same thing with translations and reflections. All three of those, these are the three rigid motions. They do not change the size or the shape of the original figure. It preserves the size and the shape of the original figure. All right, so on page 105, we start our extra practice. And for the first three, it says graph the image of the polygon after a rotation of the given number of degrees about the origin. So first of all, an image, remember, is the terminology we use for just the new figure that we're going to be putting down. The one that's there already on the graph is called the pre-image. That would be the original. And our rotation here is giving us the number of degrees. You can see the 180, the 90, and the 270, and it says it's all about the origin. So we're going to go back to our core concept all the time and just remember what these were again. We got to remember what we're going to do to our ordered pairs. But first, we got to get the ordered pairs. We need to know what the ordered pairs for each vertice are, which is the J, the K, the L, and the M. And let's take a look at our coordinate plane, see how it's numbered. It is numbered where every box is worth 2. So we got 2, then 4 each direction. So we got to keep that in mind as we're going to write these down. So let's start with J. That's going to be -2 and a positive 4 for j right there. So let's put that over here on the side. For k, we're going to be going this way, negative 5, but then only up 1. So negative 5, 1. For L, we're going to go negative 2 this way and down 2, so negative 2, negative 2 for L. M is in the first quadrant, so it's both positive, positive 1, positive 1. So right 1 and up 1, and we get to the corner of M. So now we need to go back here. We're going to do it 180 degrees about the origin. Let's take a look at that again. So for 180 degrees, we are keeping the numbers in the same spots. We're just going to change them to their opposites. So just change the sign to its opposite for both x and y. So we're going to do this. Just the x will become a negative or its opposite. The y will become its opposite. So basically, if we were to fill these in here, so if we just plugged in the x number here, negative times negative 2 would become positive 2. And then 4 goes in here, it becomes negative 4. That's going to be what our new j is. It's going to be put a little j with a little prime slash up there. So we call it j prime is the positive 2, negative 4. They just change their opposite signs. So do the same thing. Now you get the idea of what's going to happen. This is going to become positive 5 and negative 1 for our k prime. And for this one, they both become to positive 2, positive 2, positive 2 for L prime. And this will become negative 1, negative 1. They'll just change their opposite signs for M prime. And then we just want to graph it. We want to put it on here. It says graph the image. So we are going to put it on our coordinate plane. Make sure you do that as well. So plot each of these points. So for J prime, we'll put that down here. That's going to be 2 to the right, 4 down. K prime, 5 to the right, 1 down for K prime. And then positive 2, positive 2. So one box this way, one box that way for L prime. And then negative 1 is in the third quadrant. So half a box this way, half a box down. And then just connect your dots together to make your box right there. And that one's done. Then for number 2, same thing. We need to know what are the ordered pairs for basically R, S, and T right here. So we need to get those ordered pairs down first, and then we can look at see what we're going to do to those ordered pairs. So for our first one, R, you can see again the same thing's happening here as far as every box is worth 2. So it's going to go 2, 4. So it's negative 4, but it's on the x-axis, so 0. Negative 4, 0 for R. And then S is going to be just half a box, so it's negative 1 and positive 5 for S. And T is at right here, negative 5 and positive 1. So negative 5, positive 1. But now we need to go back. We don't, be ashamed of going back to these core concepts. You want to keep reviewing them every time. So this core concept, we want to keep going back and say, okay, 90-degree rotation, we're going to do this. Eventually, you would need to know this information. So keep going back, looking at it for right now as you're doing your assignments. Even when you get to do your quiz, you can use your notes and you can go back to it then as well. So for this one, you can see 90 degrees is we are going to switch the numbers, and the x number will turn to its opposite. The new x number will turn to its opposite. So the old y number changes to its opposite. And so we come over to here. So we are going to switch these numbers, and so we're going to do this to it basically. It's negative y and an x. So if I put in, my y is here, 0. If you put 0 here, negative 0 is still going to be 0, and x is going to stay the same. That's what it's saying back on our thing here. It's going to be changing. This one's changing to its opposite, but this one's going to stay the same. The original x number will stay the same. The original y number is the one that changes to its opposite. So that will make a r prime of just 0, negative 4. And again, we're going to switch them. So the negative 1 is now your y, but then 5 comes here, and 5 is going to become negative. So negative 5 and then negative 1. So negative 5, negative 1. You can always just think about putting them into this. That's why I write this down up here. It's a good thing for you to do too. Every time you do one of these problems, write down what are you going to do to the x and y. It's going to be negative x or negative y and an x. So when I do t right here, I can be filling in the x here. So just negative 5 goes here. Fill in the 1 here. Now it becomes negative 1. Negative 1 and a negative 5 for that one. And then we're going to plot our new points, and we'll put them down on our coordinate plane. So our r prime is 0, negative 4 on the y-axis. -5, -1 is going to be in the third quadrant over here. And -1, -5 also in the third quadrant, but down this way. So -1 this way and down 5. And then just connect your dots together. And it should be the same shape here. It just rotated 90 degrees. It went from here, rotated about the origin, 90 degrees. Now if you were to draw, when you're doing any kind of 90-degree rotation, 90 degrees rotation, any of those kind of things, you can always see if you draw from R here to the origin, and then this one here, you can see the right angle. It's 90 degrees. That's your angle of rotation. On the next one it says 270 to these points. We got to figure out the points first. Again, the same thing. Every box is worth 2. So A is 1, 4. Right there. For B, we're going to be 4 and then 3. So 4, 3. C, we're 3 and then 1. So 3, 1. And D, we're 1 and 2. So 1, 2 for D. And then for 270, we got to figure, okay, what are we going to do to our X and Y's here on the 270? What's the rule for 270? Come back to your core concept. For 270, you are switching them, and it's going to be the other way around, where the Y is going to be the opposite one, so the new Y will become opposite, or the original X that's changing to be in the Y spot is going to become its opposite. So the X number that's originally there, that's going to be over here. So it's going to be Y here now, and the negative X is over here. And so that's why I'm going to write down up on top here is Y. Y is now first, and then it's a negative X for the second one. So your Y, which is 4 on this one on A, so 4 is first, and then 1 goes here, now it's -1. 4, -1 for A prime. And then here you're going to put Y first, so 3 goes first, and 4 goes here, now it's -4. So 3, -4 for that one. This one, Y goes first, so 1 and 3 becomes negative, so 1, -3. And this one, 2 goes first, and then 1 goes second, becomes negative. So 2, -1. And so now we'll plot these new points on our coordinate plane here. A prime is right there in the fourth quadrant, right 4 and down 1. B prime also in the fourth quadrant, and all of these should be in the fourth quadrant because your original are all in the first. 270 will put them over here in the fourth quadrant. So that's why we got B down here, which is 3 to the right, 4 down. And then 1 to the right, 3 down, we're going to be over here for C prime, and then 2 to the right, and then 1 down, and that's your D prime. And then just connect your dots together to make this one. This is more of a kind of a, it's a quadrilateral. It's not a specific type of quadrilateral. We would probably just call it a quadrilateral for that one because it's 4 sides. All right, for 4 and 5, now you can see it says composition. It uses that word because it gives you 2, gives you the rotation with another transformation. So it's wanting you to use the rotations on these for sure, but sometimes it might be a reflection, sometimes it might be a translation, or it could even be 2 rotations, I suppose. But notice that sometimes the rotation is going to be first, sometimes the rotation might be second. So you just do the first one, and then you just do the second one. So we just do one at a time. So on number 4, it says reflection in the x-axis. Well, first of all, we need to know what our points are. These are just lines here, so just 2 points that create the line. So we need to know what the points are for M and N. So the starting off is exactly the same. Know your points. Know your original points for the x and the y. So M on this one, and it's all going by 2's again. So M is -4, +4. N down here in the third quadrant is going to be -1 and -2. So that's where we start from. But now what do we do to the x and y's here is to do a reflection in the x-axis. So we're going to reflect this here over this axis. Well, now we got to go back to the core concept, what that was for reflections. So we got to go back several pages. This is back on page 100 on this core concept. So look back at that page there in your notes. You want to go back to this one. So this core concept and the new one that we talked about for rotations are the ones you want to keep going back to because you need to know what these rules are for the reflections and the rotations. The transformations, the rule is kind of right there in front of you, but for reflections and rotations, you're going to want to keep going back to these core concepts. So you might want to put a little marker in there, a little tab even on these pages, so you know quickly to reference, go back to those tabs in your notes. So here it is, x-axis. What are we doing to it? We're going to keep them the same way, but just the y is going to turn to its opposite. That's the only thing that's going to change. The y number will change to its opposite. So we'll go back here, and so for reflection in the x-axis, this is what we're doing. X will stay the same, but the y will become its opposite. They stay in the same positions as well. So -4 for x is still going to be -4, but then 4 goes here and becomes -4. So that's going to change to the third quadrant right there. So -4, -4. And then for the n, the -1 stays the same, but -2 will become its opposite and become +2. So it's -1, +2. And now we'll plot these points, and we're going to mark them as prime, just the one mark here. So plot those 2 points, and you connect the 2 dots to get your line. So M prime is down here in the third quadrant, N prime there is in the second quadrant. Now, from this blue one here, I'm now going to do the rotation of 180 degrees about the origin. So about the origin just means we can use the core concept with these 180 degrees. So we go back to knowing what are we going to do to these blue points here now with a rotation of 180. So when we go back to that core concept, so you got to keep going back. So basically 105, you want to put a marker on that page to keep going back to this one. So it's a rotation of 180 degrees. There it is. They stay the same direction, so x and y will stay in the same positions. You're just going to change both of them to their opposites. And so that's what we're doing on this one. The x and y stay in the same positions, both change their opposites. So here for this one, they're both going to become +4s for m double prime now. So this will be m double prime with 2 marks, and now they're both +4s because you're going to change both signs to their opposites. This one will become +1, -2 for the n double prime. So +1, -2, both will change their opposites, and now we plot these 2 points here, the red points that I got, and you can see the m is in the first quadrant where they're both positive, n is in the fourth quadrant. You got +1 and -2, and you connect the dots together, so it rotated around. So now m is up on top, n is down below. It looks almost like it did a translation, but it didn't, because see how the points are been flipped around. You've been spun around here. All right, for number 5, we're starting with the rotation, 90 degrees about the origin. First of all, then we're going to need to know what these points are. What's m and n first? So again, going by 2s. So -2 and a -1 in the third quadrant for m. And then for n, we're in the first quadrant, so it's +3 and +1. So now what do we do to these points for the 90-degree rotation about the origin? Again, let's look back at that core concept on page 105. We're going to switch them, so they will switch, and then that y will become now a negative. So it'll be -y first, and then just the x second. And so that's what we'll do here on this rule. So it's going to be -y first, and then x second. So starting off with your y, so -1 goes here, but it changes to its opposite. So it's going to be a +1 first on our new one, and then -2 second. So 1, -2 is our m prime. For the n prime, 1 is y. That's going to go first, but it's going to be changing to its opposite. So -1 and then 3 after that. -1, 3 is our point for n prime. Go ahead and plot these 2 points and draw the line, connect the 2 dots, and it should look like this. So n prime is up here in the second quadrant, m prime down in the fourth quadrant. So the next thing it says to do a translation. Now here's where we don't need to go back to a core concept, because this shows us exactly what we need to do. It tells us we're going to just move it 2 units. We're going to move each of these points 2 units to the right, because it's +2, and 3 units down. So you can actually plug in. So there it is. It's like what I did here. You know, I can plug these numbers in. I can take for this one 1, and now it's just going to be 1 plus 2, which is 3 first, and then -2 goes here, and it's -5. -2, -3 make -5. So it's a 3 and a -5 for our new double prime point. M double prime is 3, -5. Plug in -1, so -1 plus 2 is +1, and then 3 going here, 3 minus 3 is 0, so it's going to be +1, 0. 1, 0 is for n double prime. And now you plot these 2 new points. So this is going to be 3 And the -5, it's going to be down here in the 4th quadrant, and then 1, 0 is going to be right there on the x-axis. So there it is for n double prime on the x-axis, m double prime down in the 4th quadrant. Connect the dots together. So it just shows that you moved it right 2 units and down 3 units. Alright, let's take a short little break here for our joke of the day. Our joke here is, how can you drop a raw egg onto a concrete floor without cracking it? Seems impossible. How can you drop a raw egg onto a concrete floor without cracking it? Any way you want. Concrete floors are very hard to crack. So you can drop a raw egg any way you want to on a concrete floor and it won't crack. Okay, so for 6 and 7, I want you to try now this on your own. Now that you've seen me do it a couple of times here, it's just the same as 4 and 5 with the composition. You're going to start on 6 with a rotation of 270. So first figure out what is your original m and n points, and then look back at the core concept, 105 for the rotations, and then I think it's 100 for the reflections. So go back to these two, 105 for rotations and 100 for reflections. Go back there to see what to do to your ordered pairs for each transformation, and then just also put them on the graph. So do that for number 6 and number 7. So pause the video while you're working on that, and then you can go ahead and play it and then check to see if you're correct. Okay, so hopefully you've done 6 and 7 now. You've done them on your own, and you want to just check to see if you're doing it right. So we got to first figure out what are our points here. So m is the 0.34. Again, you're going by 2's, so make sure you understand that. Going by 2's, and then n is the 0.31. And so for a 270 about the origin, what we're going to do for a 270 about the origin is that we are going to switch them. Y is going to go first, then x, but x is going to become a negative. So that's what we do over here. We're going to do this, y first, but negative x second. So as we put these numbers into here to make our new numbers, you can see how 4 is going to go first, but 3 is going to become -3. So 4, -3 for the m prime. And this one, that 1 will go first, but then 3 again is going to be -3. So 1, -3 for n prime. Plot those 2 points, and you got this down here. So you have your m prime is here, n prime is over here closer to the y-axis, and connecting the dots. Then it says a reflection in the line y equals x. So we want to figure out, okay, what are we going to do to these points now for the reflection y equals x? Go back to that 100 page. When in that one where it says y equals x, it's right here. It's going to be just switching the ordered pair. So it's just going to be y first and then x second. So now you just switch the ordered pair that you have, not the original one, the one you just did. So now you're going to switch these numbers. So for m double prime, it's going to be -3 first, 4 second. So that's what we'll do. We're just going to switch our numbers here. Y goes first, x goes second. So like I said, -3, then 4. This is going to be -3, then 1 for n double prime. And then you plot those two. And you can see now you're over here in the second quadrant. So -3 and 4, -3 and 1. Connect the dots. For number 7, knowing these points first is important. We got to know what those points are. M is just the 0.3, -3. So write 3 down 3. N is on the x-axis, so it's just -1 and 0. So now we got to look and see, okay, it says rotation first. So rotation 90 degrees about the origin. Hopefully you might be starting to get the hang of what these are. Hopefully you'll start to remember, okay, this is what I do the points every time it says rotation 90 degrees. Or reflection over this line. But if you're not sure, always go back and check the core concepts on those 2 pages. So 90 degrees about the origin. If we go back and look at our core concept, there it is. We're going to switch them, and the y is going to be a negative up front. So we're changing the y, but it will be moved up front, and x will be staying the same but moved in the back. So we'll come back over here. So y is going to change. It's going to be +3 up front, and 3 goes in the back. So it's just 3, 3 then. For that one, that's what's happening here, 3, 3. And then for 0 is going to go up front. It doesn't change really because you can't really change the sign of 0. -1 goes in the back. So it's just going to be 0, -1. You can always plug them into here, right? You can see how you could do that. So if you plug 0 in, -0 is still 0. And then -1 is -1. Plot these points, and that gives you this line as you connect the dots together. And then for the next one, it says a translation. It tells you what to do. You just know to put your numbers in here. So your numbers from this one. So 3 goes here. 3 minus 5 is -2, but 3 will stay the same for y. So -2 and 3 for the m double prime. 0 goes in here. So 0 minus 5 is -5 for x, but -1 stays the same. So -5, -1. And now we plot these 2 points on our coordinate plane and connect the dots to make our line. Okay, so number 8 and 9 are essentially doing the same thing. It's a composition, so you can see sometimes we start with rotation, then reflection. This one's translation and rotation. Notice there's going to be a rotation in every one because we're in the rotation section here. And so definitely we want a rotation at least once in each one. But what we have to do this time is we actually have to draw the original figures. So back up here, the original figure was drawn for us, and we had to figure out what the ordered pairs were. Well, now they give us the ordered pairs. They want us to draw the original figure and the 2 new figures, so the image and the second, the double image. So just plotting these points, J, K, and L, it's going to start the same in both of these. So as we plot that first one, 2, 3, now notice it doesn't give us any numbers here. It doesn't say go by 2 or go by 1 even. So you can kind of decide what you want to do, but typically if it's a small coordinate plane, it only goes 4 boxes. And we have 3, so you might want to use the same as what we did up here. I might just still continue to use every box being worth 2, which is what I did. So there's our original there. So 2, 3 for J. So 2 and then up 3 for J, 1 and -1 for K down here in the fourth, and then -1, 0 right up there on the x-axis, and then you can connect the dots to make your triangle. I'll be completing this triangle in a minute here because I had erased a few things. So the first thing now to do to this and these points here, to do these original points, is to rotate it 180 degrees about the origin. So we can go back to our core concept there on 105, look at the 180. It just tells us keep those x and y's in the same position, just make them opposites. So we'll keep the x and the y's the same, but they're all going to be just turning to their opposites. So we'll talk about J prime. J prime here is going to be -2 and a -3. So that's what we were doing here. It's just going to change both to their opposites. So there's J prime, -2, -3. This will become -1, +1 when they change both opposites. And L be +1 and still 0 for that one because you can't change the sign of a 0. So it's just 1, 0. And then we go ahead and plot these points on our coordinate plane. Again, every box is going to be worth 2 for this one. So J prime down there in the 3rd quadrant, and K prime up there in the 2nd quadrant, and then L prime right there on the x-axis, just 1 to the right. And again, you can now connect the dots together to complete that triangle. So as you complete the triangle, there you have it. So there was the original in blue, and now you can see how it was rotated around the origin, 180 degrees. Then it says reflection in the line x equals 2. And you might be going back to your core concept. Oops, actually not there, right here. And you can see, well, that does not show up. X equals 2 is not one of the lines. We only have 4 lines here that show up to do the points. So these are the ones x-axis, y-axis, or the line y equals x, or the line y equals -x. We have those as rules, but there is no other rule for a line that's x equals 2 like we have here. So what we have to do when it's x equals a number is we have to kind of draw the line of reflection. So just go where 2 would be, which is just 1 box this way. It's going to be a straight line going straight through 2. It would have to not touch y, it would have to be parallel to y because there is no y in this equation. So it's just a vertical line going right through there. I'm going to kind of make it a yellow dashed line so you can see it. And what we want to do there is just map each point for J double prime, K double prime, and L double prime. So starting off with the J double prime from this point, here's the J prime. and that is, as you can see, it's a -2 and -3. So from your line of reflection here, it is exactly 2, 4, 4 to the left of that line of reflection. So we need to go 4 to the right, which would be right over here, 2, 4. It's going to be on the same y, so the y's will always stay the same here. So the y for this is -3. It's still going to be -3. So it's just going to be moving right over here. Because it doesn't say you're not changing the y is going to stay the same. You're going to change the x. So the x number is going to be now going this way 4 units. So that gives us an ordered pair just right here. Now I'm not even going to write the ordered pair. It doesn't say to. We just need to get that figure on our coordinate plane. So it's right over here, 4 units this way. For the k, 1, it's right at 1 there on the y. It's going to stay at 1. Right up here, here's -1 and 1. So there's our k prime. Don't look at this one here. You got to go off of the k prime. This point here, -1 and 1. And for that one, it's going to stay on this line, so it's still going to be at 1 for y, but the x is going to change. So it's 3 to the left of your line of reflection, so 3 to the right. It's going to put you right here in the middle of that box for k. And so there's for k double prime. And then for the L double prime, 0 is going to stay the same. So right now it's still going to stay on the x-axis. 1, 0 is here, and it's just 1 away. So 1 on this side to the right is going to be just right here. That's where your L double prime is. Connect your dots, and you got your triangle. That's what you needed to do. All right, so for number 9, I'm going to have you try this one on your own. So the first thing to do is plot the points again exactly the same way as we did this one. So that was our blue one was the original on this one. So you're going to plot that same triangle over here as well. And then go off of that to do a translation. So translation, there is your rule right there for translation. And then look for the rule for the rotation 270 back on page 105. And then, so pause the video, do number 9, and then play it to check your work. Okay, so here we go with number 9. Again, your triangle should be on there. So there was our original triangle. Oops, I made a mistake there as I drew this out. Oops, I erased the wrong triangle. Our original should have been up here. So this is actually the prime triangle. So let's just go off of, okay, so if I did this to these, what am I going to do to all of these to get this? So 2 goes into here, 2 minus 4 is -2, and then 3 goes here, 3 minus 4 is -1. So for J prime, it's -2, -1, which actually is this point here. I think I got messed up with my colors. That's what happened. So there it is, -2 and -1. -2 and -1. Actually, it looks like more like -1, -1, almost. It really should have been -2, -1. I probably made a mistake on that one as well. Maybe it should have been over there a little bit. All right, our next one would be 1 going in here. So 1 minus 4 is -3. -1 going in here, so that makes -5. So -3, -5. Is that what my K is here? I believe so. -3, -5. So I was right on K. Yeah, J is a little off there. And J should have been over here. My bad. So that's where that one should have been. And then for L, L goes in here. -1 and -4 make -5. And then 0 minus 4 is -4. So -5, -4. So -5, -4. I'm on the money for L prime there on that one. And so that's that one. And then we want to see, so there's these points here. That was the original one. This was the original. I erased it too soon. So that was our original, and this is our image after the translation. And so now we want to do the rotation of 270 about the origin. So now we're going to be working on changing these points here. And the rule for 270 about the origin, if you went back to your core concept, that was switching the x and the y, but the x number becomes negative in the second spot. And so let's put that down here just to keep it in our minds. We can actually see the rule and plug it in. That's why I do this, so you can actually plug it in. You should always write this out. What are you going to do to the x? What are you going to do to the y? Y is going to go first, but it's going to stay the same. So if you start with J here, -1 is going to go first, so you start with -1. -2 second, but it's going to turn to its opposite and become +2. So -1, +2 for that one. on the K prime one. So negative 5 goes first, stays the same, negative 5's first. Negative 3 becomes positive 3 second, so negative 5, positive 3. And here's negative 4 going first, but 5 is going to be second, but turning to its opposite. So negative 4, positive 5. And then as you plot those points, you'll get your second triangle. And so there's J double prime with negative 1 and 2. Boy, I messed that up too. So negative 1 and 2 should have been actually right here. I'm not sure why I did that. So messed it up again. You shouldn't mess yours up. You can go ahead and make sure yours is correct right there. It should have been 1 box up for negative 1, 2. That's negative 1, 1. And then the K prime, let's see if I did this one correctly here. We got negative 3, or down here, sorry, negative 5 and 3. So negative 5, 3, yep, that one was correct. And then this one, negative 4, 5. Let's see if I did that one right. So negative 4 and 5, yep, got that one okay too. So again, just the J. Wow, the J's here on these two, I messed them both up. So they should have been a little different. Let me mark them where they should have been. Maybe I'll do a different color here. Maybe I'll do a bit of a purple. Oops, there we go. Purple color here. So this one should have been at negative 1, 2. It should have been right up in here. So it should have been right there. And then this one here was negative 2. Negative 2 this way, and negative 1 should have been right here for those points. So I messed those triangles up a little bit, but you can fix them on your paper. Alright, so on page 104, there's a couple of vocabulary words to put down here, and the first one there is rotational symmetry. And what a rotational symmetry is, it's a figure in a plane has rotational symmetry when the figure can be mapped onto itself by a rotation of 180 degrees or less about the center of the figure. So that's what you kind of want. You can write that down for rotational symmetry, that the figure can be mapped onto itself by a rotation of 180 degrees or less about the center of the figure. And then this point is the center of symmetry. So the center of symmetry is the center of the figure. That's that point. And so we can see this little wheel here, this little thing, this little pinwheel. Maybe you played with these when you were a kid, you used to blow them in the wind. But if you were to rotate it, does it have rotational symmetry, which means it can be mapped onto itself from 180 degrees or less. And so you can see as it goes 45 degrees, no, it's not the same as originally at 0 degrees. As we continue to go, when we get to 90 degrees, rotating it, then it looks like the same as 0 degrees. And also when we get to 180 degrees and rotate it, it also looks the same as the 0 degrees. So this one had, and you can see your center point would be right here, kind of a little orange point then. And so you can see it has rotational symmetry, and it has it twice from between 0 and 180. So one at 90 and another one at 180. So I have a little video I wanted to just show you that might describe the difference between reflection symmetry and rotational symmetry. Okay, so far the lady here has drawn an isosceles triangle, and she drew a center line right down the middle, and that's the line of symmetry right down the middle of this figure. So I'll play the video. Her accent is kind of fun to listen to.
If this part is flipped to the other side, we see that the two parts match exactly. And that's why we say that this shape is symmetrical. This is called reflection symmetry. Why is it called that? Let's see. If we take one part and keep it against a mirror, we will get the original shape. The reflection of one part completes the shape. But wait, what is the other kind of symmetry? Do we have another kind? To know the answer, here's another figure for you. This figure is made up of 6 squares to be precise. Now I want you to tell me if this shape has reflection symmetry or not. Can we draw a line through it such that the two parts formed match exactly with each other? If we try out different lines, we realize that no such line can be drawn. This shape has no reflection symmetry, but what this shape has is rotational symmetry. Yes, rotational symmetry. What does that mean? As the name suggests, let's try rotating the figure about its center point. And what does rotating about a center point mean? Take the example of this triangle. If we rotate it about its center point, it will rotate like this. If we rotate it about this point, it will rotate like this. And if we rotate it about one of its vertices, it will rotate like this. The shape will rotate differently depending on the point around which it is rotated. Now let's come back to our figure. We rotate the figure completely around the center point once and see how many times it looks exactly like the original one. Rotating it completely means rotating it by 360 degrees. Let's have a counter on the right which counts the number of times the rotated figure looks like the original. Let's start. Now the figure rests at 0 degrees. After rotating it by 90 degrees, we get this shape. It's not the same as the original. The counter is still at 0. Okay, so let's rotate the original shape by 180 degrees. And we see that it looks exactly like the original shape. It fits in perfectly. We see an increment of 1 on the counter.
Okay, so hopefully that gave you the idea there. I mean, her accent's kind of fun to listen to. But the difference there between the rotational and the reflection symmetry is your reflection, you're flipping it over a line. It's mapping onto itself over a line of reflection like a mirror line, and then rotational symmetry is spinning it, turning it around a center of symmetry. That would be that point, that center point in the figure, as we can see here on this little pinwheel. And so I know she goes on to 360, but we don't usually do that here. We're going to just stay at 180. So it says the figure above has point symmetry, which is 180 degrees rotational symmetry. So you could say, yes, it has rotational symmetry, and it's going to map onto itself at 90 and at 180 degrees. That's what we want to do for our problems here. So let's give just try a look at a few of these here, just as a way of just getting an idea of rotational symmetry. It says, does the figure have rotational symmetry? A is a parallelogram, we got a regular octagon, and we got a trapezoid. So if you can think about, it's going to have a center point, and you're going to rotate it, spin it around that center point. So if you can think of that in your mind as you do this. Obviously, we don't have the technology in our, right on our papers to be able to do that. You might be able to spin it perhaps on your paper, but for this one, you can see that it does. This one has rotational symmetry because it maps onto itself when you rotate it 180 degrees. So if you can map it back onto itself after a 180 degrees, it does have rotational symmetry that way. For this one, yes, it does several times, in fact. As you rotate this regular octagon around, yes, that's going to have, whoops, push the wrong button, back over to here. So yes, that one has it several times. So once, twice, 3, 4 times there, one at 45, one at 90, one at 135, and then again at 180. So 4 times it's going to be mapping onto itself as it rotates it around. And it could rotate it to the left, it could rotate it to the right, it doesn't matter. For the trapezoid here, this one does not have rotational symmetry because as you rotate it around, even when you get to 180 degrees, it's not going to be the same. You're not going to be mapping it onto itself until you get back to the 360. So it doesn't have rotational symmetry. It does not have rotational symmetry because no rotation of 180 degrees or less maps the trapezoid onto itself. All right, so I want you to try these 3 right here on the bottom of page 104. So go ahead and just copy the figure down. Rhombus, octagon, it's an 8 figure, it's not a regular one, but just go ahead and copy it down, kind of looks like a Chinese star there, and then a right triangle. So copy 7, 8, and 9 down on the bottom of 104. Copy these figures. It's not on your extra practice. This is going to be in the notes section right there on page 184, and then do the same thing on these. Go ahead and pause the video and see, does it have rotational symmetry, and if it does, tell at what degree it does have rotational symmetry. How many times and like what degree. So go ahead and pause the video and do that for 7, 8, and 9. Alright, so hopefully you've finished 7, 8, and 9 here, and you're looking to see, does it have rotational symmetry as you turn this? And this one does. Here, as you rotate this around, it'll map onto itself at 180. So this one you could say yes, and it's only going to do it at 180. So you want to say 180 degrees is where it will map onto itself. For this one, it will have rotational symmetry. In fact, it'll have it a couple times, because as it goes to 90, it'll be onto itself right here at a right angle. As it goes to 90 and as it goes to 180. So twice for this one. So you're saying yes for rotational symmetry on this like Chinese star, and it's at 90 and at 180 it'll be mapping onto itself. For the right triangle, if you were to spin the right triangle, this one you'd have to say no, it does not have rotational symmetry. So there's no way that this is going to map onto itself from 180 degrees or less. It'll only map onto itself when it makes a full rotation, which is 360 degrees. Okay, so back to our just last two problems on our extra practice, page 106. We're asking the same question, determine whether it has rotational symmetry. So just that question alone is an important question. Does it have rotational symmetry? And then if it does, describe any rotations that map the figure onto itself. So that's where we're describing the degrees, how many degrees until it maps it onto itself. So for 10, if you think about the center point being right in the middle, as you turn it, for this is a pentagon, it's a regular pentagon, all the angles are the same, all the sides are the same, so it's a regular pentagon. It will map onto itself once it gets to here. Once it turns from this corner to where this one's at, it will map onto itself. It'll do it again when it maps this corner down to here, which is all less than 180, because 180 would be making this point right up on top being down at the bottom, flipping it all the way around. So it's going to map it onto itself twice. So we'd say yes. The first time we'd have to figure out, okay, well 360 degrees is a full rotation, and you have 5 stops here. 1, 2, 3, 4, 5. The fifth stops at 360. So if you divide 360 by 5, that'll tell you how much each rotation would be. So if we just did that real quick, 360 divided by 5, that's going to give us 72. So each of these stops here will be at 72. So 72 here, 72 more here. So that's going to be, for the first one, it's 72. At 72 degrees, it'll map onto itself. Then 72 plus 72 more is 144. So at 144, it'll map onto itself down here. And then that's it, because then after that, when it comes over to here, you're more than 180. So just those two. On this one, number 11, if you were to spin this around on a center of rotation, right there in the middle of the figure, it is not going to map onto itself at all until it gets back to its full rotation of 360. So you just have to say no. No rotational symmetry for this one. All right, so that concludes our lesson now for 4.3 on rotations, and I'll see you on the next lesson.